Hey there, in this lesson we're going to take a look at how to use interfaces to design collections of classes that all share common behavior. There's a lot of stuff in this lesson, so strap in and don't be afraid to pause and rewind in case you need to watch certain parts a couple of times. We're going to talk about what an interface is and why it might be helpful. We're going to talk about both how to write interfaces and how to implement them using classes. And then lastly, we're going to talk about how you can actually create object reference variables using your interface types so that you can gather objects that implement the same interface together into collections, and how to convert back and forth between an interface variable and the class that is actually implementing it. Okay, so what's an interface? An interface is essentially a way of describing a set of behavior, that means methods, that all classes that have a certain property should have. So for example, there's an interface called sortable, and that contains a method in it called sort. And every class that wants to be designated as sortable has to implement that method called sort. An interface contains method headers without actual method code in them, and it doesn't contain any variables. It's really just a specification for a set of methods. Why is that helpful? Well, a bunch of reasons. One is that it allows you to, again, create these collections of classes that have similar behavior, and that you can be sure that they are all doing the same actions, even though they don't have to do them in the same way. Another big benefit is that it allows you, and we'll look at this later, to have, say, an array containing the different individual classes as long as they all implement the same interface. So you could have an array list of type sortable and then have it contain 7 different types of classes. As long as each one of those class objects implements sortable, you can store them in an array list of type sortable. And that can be hugely time-saving when it comes time to getting a bunch of different kinds of objects to all do the same thing. It's also just helpful from a design standpoint. It helps you design your program more effectively if you have to think about, well, what are the sets of methods that some of my classes have in common? It encourages better program design. What does an interface look like? Well, like we said, an interface consists of, it looks a lot like a class, except we say public interface instead of public class. We still list methods just like we would in a class, but instead of writing code for those methods, we just use a semicolon. And again, you can't have any data inside of an interface. It's just a list of methods. You should still write comments, though. I didn't write comments here, but you should still document your interface using java.comments. Now, once you've defined your interface, how do you actually use it when you're designing a class that needs to use it? That's where you have to use the keyword implements. And we've seen this a little bit for example, in the mouse handling classes that you've had to write. All of those have consisted of, public class myMouseHandler implements mousehandler. And then you remember there were those 5 methods, and you had to include them all, even if you didn't want to write code for all of them. That's because of the rule that you have to write code for every method in an interface if you choose to implement it. One more quick note here. You can implement more than one interface if that's useful for you. You just list them all with a comma. So you could say implement sortable, comma, mousehandler, comma, collection. I can't imagine why you would ever include those 3 together, but what the heck. So here's an example. We've got this class truck, which implements the interface called vehicle, just like we've seen before. And so we would have to have definitions for each one of those vehicle methods. What I usually do is I just select all the methods inside the interface and I just copy and paste them into my class, and then I can just replace the semicolon with curly braces containing the code that I want to use. And if I wrote comments in my interface, I can just recycle them. Now, let's talk about how you actually use how you can use interface variables to reference the objects in your class. Again, as long as the object type implements the interface, you can assign it to a variable of that interface type. So if you take a look down below here, we can create a truck object called monster truck, and then we can assign it to a vehicle variable named truck2. Because truck implements a vehicle, that works fine, and there's no problem with that. The only thing you can't do is you can't create a new object of an interface type. You can never say new vehicle, because interfaces are not classes, they're just lists of methods. So you can't do that. The nice thing about having interface variables is you can call, using those interface variables, you can call any method that's part of that interface. So again, here's an example. Suppose we have a class called plane, which implements the vehicle interface. I can create a new plane and assign it to a vehicle variable named jet. And then because jet is a vehicle, I can call the drive method. Remember back when we specified vehicle, vehicle has a method called drive. It doesn't have a method called takeoff though, so if I tried to say jet.takeoff, I would get a compiler error. Even though jet is pointing at a plane object, because the type of the variable is vehicle, Java doesn't know that it points to a plane. And so that would cause us problems. And in fact, in that situation, if we wanted to call those plane methods that only belong to the class plane, what we have to do is we have to convert that variable to a plane object. And you can see how to do that here. We would create another variable, this time of type plane, and then we would convert jet to type plane by putting plane in parentheses. That's called casting. You might have seen that a little bit earlier if you've ever tried to convert from a double to an int and you put the word int in parentheses. That's the same thing, except now we're converting from an interface variable type to the class type that it actually implements. Then we could say the jet.takeoff, because Java knows that the jet is a plane, whereas Java didn't know that jet was a plane because we declared it as being of type vehicle. I know that's a little complicated. If you get more practice with it, I think it'll make a little more sense. Let's take a look at an example of how that works. So here's my vehicle class. Here is a plane class which implements vehicle. And so, I've got class variables in here. That's fine. Remember that because it's a vehicle, I have to implement getType, I have to implement drive, and I have to implement printStatus. I've also decided to implement a couple of plane-only variables, takeoff and land. That's fine. You can always add more code to your implementing classes. You just have to, at a minimum, implement all of the interface methods. Same thing with truck. I've got a truck that implements vehicle. I've got some unique class variables. I've got a method that's only for trucks, and then I've got all of my interface methods here. Now what's the big payoff for that? Well, the payoff for that is an example of what you see here in our vehicle test class. So I've created a truck and I've added gas to it. I've created a plane and I've made that plane take off. And then what I've done is I've taken both of those two objects and I've put them in an array of type vehicle. Notice that even though they're different types, I can put them in the vehicle array because they all implement vehicle. And then inside my loop, let's say I wanted to tell all the vehicles in my collection to drive and then print themselves out. That works fine because drive is a vehicle method and printStatus is a vehicle method. And so when I run my program, what we see is an example of what's called polymorphism. That's a big complicated word, but essentially what it means is that in my vehicle array, if this item from my vehicle array is a truck and I tell it to drive, it's going to use truck's drive method. If the item that I pull out of my array is a plane, then when I tell the plane to drive, it's going to use the plane class's drive method. So Java knows which method to call depending on what the actual type of object was when you created it using new. And that's what polymorphism means. So, kind of reviewing all the stuff that we've talked about the fact that an interface is a set of methods that you can have multiple classes implement, that you have to implement all of the methods in an interface in order to use it in your class, and that once you've done that, even though you're creating objects of those individual classes, you can actually assign them to variables of your interface type. And as long as the methods are defined in that interface, you can call them from that variable, even though you can have that variable pointing to multiple different classes that all implement the same interface type. And that gives us what we call polymorphism. All right, you're all set.